This training will cover the fundamentals of what an HVAC economizer is and how it works. I'll begin with discussing rooftop units, then the parts of rooftop units that are used with economizers. Next, we'll look at the various components necessary when using an economizer. Then we'll look at each of the different types of economizer logic, dry bulb, enthalpy, etc., and what sensors are needed for each. Lastly, I will cover, briefly, some ways to save even more energy with economizers. There are many types of HVAC systems in a commercial building, but today we are going to concentrate on rooftop units and the ability to use outdoor air for free cooling or economizing. These economizers bring cool outdoor air into a building to cool it. Economizing is a method to save energy in a building by using outdoor air for free cooling. These economizers are also called airside economizers. Economizers can be added to any air handler with access to outdoor air. The standalone economizer controllers discussed in this training are typically found on packaged rooftop units ranging from 3 to 25 tons of cooling. A commercial building can have one or many rooftop units. In a typical rooftop unit, the return air is ducted from the building to the unit where it is mixed with outdoor air for ventilation, then conditioned for heating or cooling and returned to the space. An economizer section can be added to most rooftop units either in the factory or in the field. The economizer section consists of the sheet metal housing, dampers, sensors, and controls to use outdoor air for cooling. To use outdoor air for free cooling, an economizer uses dampers with linkages and actuators and controls. The outdoor air sensor is used to measure the outdoor air to determine if it is cool enough for free cooling. Here is the mixed air sensor. The mixed air sensor is used to ensure that the supply air is not uncomfortably cold. The controller will mix the outdoor air and return damper to keep the supply air at a good temperature for cooling. Sometimes, instead of mounting a sensor in the mixed air, a similar sensor is mounted downstream from the coil. Then it is called a discharge or temperature sensor. But in either case, it is used to measure the temperature of the air being supplied to the space. A simple economizer will use two sensors, the outdoor air and mixed air sensors. These are both wired to the controller. The thermostat usually has two stages of cooling. When the thermostat calls for cooling, the economizer controller will choose to use either free cooling or mechanical cooling. If this cooling is insufficient, the thermostat will call for second stage cooling, and the economizer will bring on mechanical cooling along with the free cooling. This is common and called an integrated economizer. Another function of the thermostat is to signal the controller that the building is occupied or unoccupied. The actuator opens the outdoor air dampers and closes the return air damper. Usually one actuator is used for this. However, sometimes each damper has its own actuator. When one is used, it may be foot-mounted with linkages to each damper, or be directly mounted on one damper with linkages to the other. Lastly, the outdoor air hood allows air in but keeps the weather out. When the thermostat calls for cooling, the controller checks the outdoor air temperature, and if it is cooler than the preset temperature, then the controller will operate the actuator that opens the outdoor damper and closes the return air damper. In this example, the outdoor air temperature is 60 degrees, and the return air is 74 degrees. When the outdoor air at 60 degrees is mixed with the return air at 74 degrees, the supply air temperature will be lower than the return air and may be low enough to satisfy the call for cooling in the space. But if the supply air is not sufficient to cool the space, then the thermostat calls for second stage cooling. This brings on the first stage of mechanical cooling to better condition the space along with the cool outdoor air. In some cases, like high occupancy, the thermostat may not be satisfied and the space will stay too warm, even with the first stage mechanical cooling operating along with the outdoor air. Some new digital economizers work with two-stage compressors and will turn on the second stage of mechanical cooling after a certain amount of time. If the outdoor air is above a preset temperature and not suitable for free cooling, then the outdoor air damper will close to a minimum position for ventilation, and the first stage of mechanical cooling will be turned on to cool the air. And, as you'd expect, if the first stage does not satisfy the thermostat, and if there are two stages of mechanical cooling, then it will call for the second stage. This is a Honeywell Jade Economizer and Prestige thermostat. When the thermostat has a call for cooling, it of course energizes Y1. But rather than being wired to the equipment, Y1 from the thermostat is wired to the Y1 input on the economizer control. If the outdoor air temperature is below a certain set point, say 60 degrees, then it will operate the dampers and allow the outdoor air to be used to cool the building. This example is a type of dry bulb control. Dry bulb refers to temperature, sensible heat, the temperature you read on a thermometer. It is sometimes also called temperature changeover for this reason. So dry bulb economizer control switches over based on outdoor temperature. Now let's look at this in more detail and then some other types of control. There are four types of economizer control: dry bulb, differential dry bulb, enthalpy, and differential enthalpy. When an economizer is configured for dry bulb changeover, the controller will use free cooling when the outdoor air is below a preset temperature. There is a temperature sensor in the outdoor air and one in the mixed air. On a call for cooling, the outdoor air temperature is compared to the preset temperature in the controller. If the outdoor air temperature is below this set point, then the outdoor air damper will be modulated towards open, and the return damper will modulate towards closed. If the outdoor air is above this set point, then the outdoor air damper will stay at the minimum position and mechanical cooling will be used. If this happens during an unoccupied period, then the outdoor air damper will remain fully closed. The mixed air sensor ensures that the supply air does not get too cold. Once the mixed air set point has been reached, the outdoor damper will hold or go towards minimum to maintain the mixed air set point. Dry bulb control is often used in drier climates where the humidity of the outdoor air is often suitable for free cooling. When an economizer is configured for differential dry bulb changeover, the temperature of the outdoor air is compared to the temperature of the return air. When the thermostat calls for cooling, either the return air or outdoor air is used to condition the space, whichever has the lower temperature. There are three temperature sensors in this system: outdoor air, mixed air, and return air. Dry bulb economizers use temperature sensors to measure the sensible heat of the outdoor air. Enthalpy economizers use a sensor that measures the dry bulb temperature and the humidity in the air. This is called an enthalpy sensor. When the controller is set for single enthalpy changeover, it uses free cooling when the enthalpy, temperature, and humidity of the outdoor air is below a set point. When there is a call for cooling, the outdoor air enthalpy is compared to the set point of the controller. If the outdoor air is dry and cool enough to economize, then the outdoor dampers will be modulated towards open. When the mixed air set point has been reached, the dampers will hold or go towards minimum to maintain the mixed air set point. Enthalpy control is often used in more humid climates. This way, the economizer will use free cooling only when the outdoor air is both cool and dry enough for cooling. Here's a graph used with an analog economizer. You may recognize the A, B, C, D lines used to configure the economizer. These were used with analog economizers for many years. This graph is what the controller uses to choose whether to economize or to use mechanical cooling. The outdoor temperature is on the bottom, and the humidity is shown on the somewhat horizontal lines. The set point for enthalpy is a point on the graph where the outdoor air temperature and the humidity intersect. Once you have set the economizer to an A, B, C, or D setting, you can look at this chart to determine if the economizer will use free cooling or mechanical cooling. Anytime the outdoor air conditions are to the left of the curve, the conditions are good for economizing. When the conditions are to the right, the economizer will use mechanical cooling. For example, if you choose the B curve and the outdoor temperature is 70 degrees, and the relative humidity is 40%, the intersection of those lines is at a point to the left of the B curve. This means that the controller would economize. If you change the setting on the controller to the C curve, that same 70-degree, 40% humidity point is now to the right of the C curve, and conditions are not good to economize. On a call for cooling from the thermostat, the mechanical cooling would be turned on. Here's a graph used for the Jade digital economizer. Notice that instead of curves, there are lines. This is because a digital economizer is more accurate and able to select the very best combination of heat and humidity at which to change over from free cooling to mechanical cooling. Still, the concept is the same as we saw previously. And the economizer control will use free cooling when the temperature and humidity is in the area to the left of the line. When the controller is configured for differential enthalpy changeover, it compares the enthalpy of the outdoor air to the enthalpy of the return air and uses the one that is cooler and drier. There are 3 temperature sensors in this system: outdoor air, mixed, and return air. The outdoor and return air must both be enthalpy sensors, able to sense both temperature and humidity. With a call for cooling, the controller chooses to cool with outdoor air or return air based on which has the lower enthalpy. Differential enthalpy is usually the most efficient method for economizer control. In this training, I've mentioned how the outdoor air damper is used for fresh air ventilation when the building is occupied. The damper is closed to a certain position that allows outdoor air to be ventilated. Many engineers go one step further and ventilate in a way that is much more energy efficient. Rather than ventilate with a preset volume of air all the time, this method, called demand control ventilation, or DCV, ventilates based on building occupancy. If there are few people in the building, then the controller will operate the outdoor air damper to bring in less air. If there are many people, it will bring in more outdoor air. The controller does this by monitoring the level of carbon dioxide in the space. CO2 is a very good indicator of building occupancy. Demand control ventilation saves energy because it brings in the right amount of outdoor air, so the heating and cooling equipment does not have to excessively condition the air. Demand control ventilation saves energy in all climates. If the outdoor air is hot and humid, DCV will reduce how much outdoor air needs to be cooled. In cold climates, it reduces how much outdoor air needs to be heated. It takes a lot of energy to move air throughout a building, and fans, like all HVAC equipment, are sized for peak loads. However, buildings operate at peak loads only a fraction of the time. Variable frequency drives, or VFDs, can slow motors down and save energy. If a motor is slowed 25%, its energy usage is almost cut in half. A VFD can work with an economizer to save energy. When the fan needs to run at full speed, it will, but it can be slowed down when less airflow is necessary, resulting in significant energy savings and a return on investment often under 2 years. To learn more about economizers, read the Design and Application Guide for Honeywell Economizer Controls. You can order the manual from Honeywell or download a copy at customer.honeywell.com. Search for Technical Literature 63-8594. This concludes Honeywell's Economizer Fundamentals. For more information on Honeywell economizers and other commercial products, please go to buildingcontrols.honeywell.com.